Hello, today we're going to talk about how to read an analog measuring device. So I have one with me here, which is a thermometer. So this is a thermometer like we would use in the laboratory. And just to be clear what we mean by this word, analog measuring device, let's talk about a contrast. The contrast is digital. And so that's what we're really used to reading as digital measuring devices. If you step on the scale, it's going to have a digital printout most of the time. You'll just look at the numbers, and that's really easy. How to read a digital measuring device is simple. You just write down whatever numbers it says. That's very simple. But an analog one, we have to decide which numbers to write down. So you can see this one. Let's just take a look at it really quick. It's a thermometer, of course, so it starts at 0 degrees Celsius in this case, 10 to 10, and then 20, etc. And that's where the numbers are written. But the tick marks are every 1 degree Celsius. So you can see it goes here, which is 20, then 21, then 22, 23, 24, etc. So what we're going to do is the simplest thing to do to begin with is simply write down the number that the last tick mark that comes before where the reading is. So we'll see if we can get this focused well here. There we go. Okay. No, there we go. Okay. So you can see that this is 20, 21, 22, 23, that the red line goes a little bit past 23. Right there. Okay, so now let's just draw what we saw really quick to make it a little easier on ourselves. So there's a big line here, and that was 20, and a big line somewhere way up here, that was 30, and then in between that there were tick marks that were 21, 22, 23, 24, 25, 26, 27, 28, 29, and then 30. So the red line that we saw came up here and went past 23 and went somewhere in this range right here. So to figure out what temperature it is here, the first thing is to write the obvious, that it's just past the 23 tick mark. But we need to do one more thing. We can actually see that this line isn't just past the 23 tick mark. This line here, this red liquid in the thermometer, goes almost all the way up to the 24 tick mark, or partway in between the 23 and 24 tick mark. So we need to estimate one digit beyond the marking shown. So to do that, we imagine that this is broken down into 10 smaller segments and try to guess at what, or estimate at where this one is. So I'm going to say 23.7. Now that is an estimate. So if you had estimated 23.5 or 23.6 or 23.8, none of those would be directly wrong. It's just an estimate, and as long as you're reading it and reading it consistently, you're better to estimate this digit than just simply round off to 23 or round up to 24. This is more accurate than it otherwise would have been, and so we always need to go ahead and estimate that final digit. When you're reading a digital measuring device, the estimation is happening, it's just that the digital device is estimating that for you. So you're not really aware that it's happening, but it is happening. And when we look at numbers then, we always go ahead and understand that that last digit, if it came from a measurement, is an estimated digit, that it might not be exactly 0.7 there. It's definitely past 23, between 23 and 24, but it's not necessarily 0.7. It might be 0.6, it might be 0.8. We understand there might be a little bit of variability in the correctness of this last digit, that it's an estimated digit. So that's it. That'll be the same on any measuring device. So another measuring device might be a ruler, for example. So imagine you're going to take this ruler, not the inches side over here, but the centimeter side here, and measure the length of this just post-it note. So you can see there that we've got it outlined here for us, or hopefully you can see the contrast of the colors there. So if you're looking at the markings here, you can see that they're every 0.1. So the big markings are 7 and 8 where the numbers are drawn. So in between that, it's 7.1 and 7.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 8. So if you're looking at this, it's a little hard to tell. We'll see if we can zoom in a little bit here. Ooh. Have to move that down a little bit to get it back in the screen. But you can see that it's a little bit beyond the 7.6 marking. So if you were to count up 7.1, 2, 3, 4, 5 as the big mark, and then 6. So we would do the same thing. We would write down, I'll just write it, oops, I'm bouncing it around. There we go, that's where it should be. Hold it in place now. There it is. So it's a little bit beyond the 7.6 centimeter marking. So we could estimate the next digit from there. So the marking is at 7.6 and it's past that digit, so we estimate what the next digit is. In this case, I'm just going to say 7.65 because it looks like it's about halfway in between. And don't forget our unit. And again, that last digit is the estimated digit. Now with this measurement that we just made, you could see that it was a little bit harder to be exact there in that measurement. The estimate might have not been quite as good as the previous estimate, and that's just the way it is. The limitations of each measuring device, how close together those tick marks are, your own eyesight, how good you can see. You could get out a magnifying glass, but that's really not necessary. It's an estimated digit, so it doesn't have to be exactly correct. It's just your best estimate at how far in between the 0.6 and the 0.7 tick marks it is. And that's it. That's how to read an analog measuring device.